Hi everyone, I'm Ophélie Choupin and I would like to present and propose to you the framework for wave energy converter and location pairing worldwide. But before we dive into the topic, I must set up what are wave energy converters, and I will refer to them as WECs in the rest of the presentation. Among the many applications of WECs, the main one is to capture the energy from the water wave, convert it into usable energy, and spread it for usage. There are many WECs and many wave energy companies, and this is where I'm stopping to tell you my story. During my engineering school, I did an internship with the goal to develop a method to pair up locations worldwide and relevant WECs. At that time, I was discovering the wave energy field, and I needed to select the best WEC for the considered location. Among the 150 wave energy companies of this slide, I contacted more than 30 of them, spread worldwide, because I thought that they were ready to sell the device. I first sent them post letters, and a month later, emails. And soon afterwards, I received an email from one of these companies saying that it had just stopped activities a month ago. And this broke my heart. I could not understand why this could happen, such a beautiful and promising field. Since that day, I started a project to try to understand where is the problem, how to overcome it, and implement the solution to it. I developed a firm idea that all WECs are good, but probably not everywhere, and I believe that one of the primary goals of this field should be to find where in the world each WEC works best. Furthermore, simple and rapid methods should be developed to pair up WECs and locations worldwide, because there is a real dynamic of the WEC-characteristics on the market. To understand the main challenge of developing such a method, due to the various WEC design, first we need to understand why there are so many designs, and this is due to the wave, and more to it to the wave climate. From the distribution of waves, the wave significant height is calculated, then the wave peak period and the wave peak direction. But already here a point, the wave significant height is sometimes not calculating using statistics, but using spectral analysis, and other wave parameters may be used alternatively to the ones shown here, leading already to very complex C-state characteristic definition. Often C-states are assessed over 1 year of wave data, and conducted over 1 year, we obtain the time series. This then enables the analysis of the wave distribution climate, often illustrated using the scatter diagram and wave roses. The spectral analysis also leads to the WEC power matrix, showing the WEC power production capacity for different wave height, period, and direction C-states. Normally, such matrix is obtained using lab tests by assuming a standard shape of the wave spectrum, but it can also be done using real C-state trials. However, studies showed that these different methods can lead to up to 16% difference in the annual energy production, which is often calculated as the multiplication of the scatter diagram and the power matrix when numerical simulations are not used. You need to consider that this AEP and potential error in its estimation is used with the cost to calculate the selected economic indicators, including the levelized cost of energy, LCOE, and the net present value, NPV. But these are based often on the capital expenditure and the operational expenditure, which are very difficult to obtain for each WEC, either due to lack of experience or to confidentiality matters. Hence, in the case of information lack, alternative indexes independent from cost have been developed. Such indexes may only need WEC and wave climate information, and then that is where things get complicated. To assess a wave energy problem, the framework should always be stated. But it is so complicated that often information is missing. Here is a summary table that could be used to frame the wave energy study. First, you need to define the study scope. Are you assessing a WEC only or a wave farm? What is your goal? Are you looking for cost operation, or are you looking for the analysis of a WEC performance. How many wave parameters and aspects do you need to consider? And then the more it goes, the more into details the framework should be explained, and the least information is generally provided, especially when studies try to work out the pairing of WECs and locations. For instance, finding the wave spectrum of power matrices is often difficult and sometimes not even achievable. Since this presentation is recorded, I would leave all the details to you by pausing the presentation in the case you would want to see more. Overall, what I wanted to show you is that in each step, a certain percentage of error is involved, and therefore a study should assess for the considered goal an analysis of what is the level of acceptable error in the final results. However, this may sometimes be really challenging, maybe due to information lack, and as currently little research has been provided about it, and those who published about it assess specific aspects of it. And as you can see, lots of aspects can be considered. Hence, the information is currently fragmented. Now, this will be the optimal use of this table, and this is an example that highlights one of the researches I am currently conducting. I am assessing a WEC individually, actually more than one, for side pairing, but only based on power energy analysis. We are assessing the use of wave direction in addition to the common use of wave height and period, and we use scatter diagram and time series techniques in order to estimate the energy production. We are also assessing two types of standard wave spectra. And finally, the WEC performance is provided by means of power matrices and numerical analysis. And we are also looking at scaling strategies. So now the objective is to simplify all of this and to elaborate a method for WEC and location pairing. Overall, two elements are necessary: which WEC for which location. And in fact, the location characteristic will already have a filtering effect on WECs. First, due to the many characteristics of the WECs, WEC classifications have been elaborated. First, they are distinguished by their working principle. Then, and this is where location characteristics play an immense filtering role, the WEC are characterized by classes of water depth and installation depth. And the last class of WECs is related to their orientation for proper functioning. This last aspect is related to the next major element to take into account in the WEC location pairing, the resource wave climate, because eventually what we seek optimally is a WEC configuration that matches the wave climate of the location best. From this, the key performance indicators can be deduced for WEC location pairing. But ideally, this should enable the assessment of waveform, and eventually the selected economic indicators can be estimated, or alternatively the key performance indicators when cost information are not available. Therefore, two cases come up. Either you would like to select a WEC for a location and the WEC configuration, or you would like to select locations for a single WEC. The resource is distinguished from the location characteristics as it has a complete research frame to it, the one we saw earlier. However, WECs characteristics and their selection also involved the resource characteristics. From it, the WEC power capacity and cost are at the same level. The WEC power must be determined to obtain an estimation of the energy production, which is related to operation and maintenance requirements from the WEC and the resource. Already, some studies stops here to reduce the number of WECs or location from the pairing. Either Fruit law scaling are used in order to select the best configuration of the WEC, or a complete database of WEC simulation is used, especially when the Fruit law cannot be applied. However, the final step is to estimate the cost of the farm and of the operation and maintenance in order to eventually obtain the selected economic indicators, also based on the energy produced, by the way. This should ultimately lead to the final WEC location pairing. However, it must be noticed that here that often costs are not available, and therefore key performance indicators non-dependent on cost may be used alternatively, or at least to reduce the set of pre-selected WEC and location pairs, for which confidential SOE analysis may be used in the future. Thank you very much for your attention, and I would like to acknowledge the overall part whom contributed to this research. Overall, I would also like to suggest for future research provided in the field to always set up their framework before start.